This is a quick video to bring you up to speed on the basics of Mathematica that we probably covered on the first day of the lab day. Just quick word on Mathematica and how you may be able to get it for yourself for your personal machine. If you go to our course links page, the Calculus 3 version right here, Mathematica download instructions, this will link you to the App State download instructions for Mathematica. So assuming that you have gone through those steps and gotten Mathematica for your machine, or assuming that you are in a computer lab in the library or in one of the computer labs on campus that has Mathematica, you will then go to this icon and find Mathematica and open it up, and that will bring you to a new notebook. Notebooks are just these plain white documents where you can type input. Okay, so the first things first. When you first come into your Mathematica notebook, if you hit enter, you will see here on the right, you will see an input, this cell that's created. This is called an input cell, and it is a place where you can input any sort of text for yourself. So for example, one thing we probably covered in the first day of class was how to define a function of one variable. And this is what we did, for example, in say calculus 1. And to define a function of one variable, we would do, for example, this. And f of x with an x underscore makes f a function of x. And we have essentially just made the function f of x what I would have written on the board, let's say in class, I would have written the function. This is the mathy version, and this is how we input it into the computer. So the x underscore says that x underscore x is our independent variable. And now, for example, we can, to execute that for the computer, to make the computer recognize that you've defined a function, you would use shift enter. So if you go to this line and hit shift enter, it runs this and creates the function f of x is equal to x squared. So for example, shift enter executes the command, and if you just use enter, this creates a new line. So if I hit enter here, it'll take me to a new line, and I can say, for example, the function evaluated at 2, enter, the function evaluated at a, the function evaluated at a plus b, okay? And these are all the options that you get. The function evaluated at 2 is 4, the function evaluated at a is a squared, the function evaluated at an input of a plus b is a plus b squared, okay? So if you'd like to get rid of the output, you can hit semicolon at the end of these, and now you'll see only the command without the semicolon. Okay. Things that you can do now with this function is you can do calc 1 things, like you can plot the function. Okay, and you could say plot, for example, the function f of x, and you want x to go from, say, -1 to 1. And this will create a plot of your function f of x is equal to x squared. Okay, so that is calculus 1 kind of idea. Let's say, for example, that you had forgotten, or you never knew in the first place how to plot a function in Mathematica. Let's say you've forgotten this syntax, or weren't sure of it even in the first place. If you hit control, where's the control? If you hit control and the equal sign, okay, what will this do for you? Control equals brings up a Wolfram Alpha window. Brings up Wolfram Alpha, where you can enter free-form input. Okay, so for example, you could say in this freeform input cell, you could say, whoops, sorry, control equals, you could say plot x squared. And if you hit shift return there, it'll give you the plotting syntax. Oops. Control equals plot x squared. Let me try that again. Shift return. So there's your plotting command, which you can then just, for example, use to say plot x squared. You can copy it and say x from negative, say 3 to 3, and you can compare these two and see what the difference between them is. This one is plotting from negative 1.2 to 1.2. If you go from negative 3 to 3, it plots the parabola from negative 3 to 3. Okay. So what we did in lab day most likely was to take this calculus 1 idea and extend it to calculus 3. So I'm going to hit enter here to create a new input cell. Everything I did here is in a single input cell right here. I'm going to create a new input cell with enter, and I'm going to do my calculus 3 example here. Okay. So the calculus 3 example, we'll try to go line by line here, is to define a function of two independent variables. Okay. And the way you would do that is f of x underscore y underscore. So x and y are my independent variables, and I'm going to just make up a function here, say like x squared plus x times y. Shift enter will create the output for there, and now I have a new function f of xy. So for example, I can say f of 1 comma 1, or f of 1 2, f of a comma b, f of 0 comma 1, for example. So f of 1 2 will put in 1 for x and 2 for y, 1 for x and 2 for y. This line will put a for x and b for y. This one will put 0 for x and 1 for y. Shift enter and we will get 3 of the outputs. Okay. So that's how to define a function. Semicolon will hide those lines. You can always go back and edit any line you want. And now, for example, I would like to create a plot of this function. So we'll say plot. This is going to be a 3D plot. I want to plot the function f of xy I just made. And I would like to plot this from x going from negative 2 to 2 and y from negative 2 to 2. And here is a 3D plot of the function that was in question. What we have lost track of is which is the x, which is the y, and which is the z axis. So if you go back to the plot command and say axes label, to get the arrow, you hit the hyphen symbol and then the right the greater than sign, and then keep typing and it'll make the arrow. So here we are creating a plot of that function, and we're going to label the axes x, y, and z. And here is our x-axis, here's our y-axis, here's our z-axis. So for example, when we looked at the function evaluated at 1, 2, we got 3 for the z value. So if you look at this plot from the top, when x is 1 and y is 2, so that's about this point right here where I'm circling. 1, 2 is 1 in the x direction, 2 in the y direction, measured from this point 0, 0 here right in the middle. And if you look at this point and focus on it and rotate this to where you can see the z value, you can see that this point right here is about at the z level of 2 if you're looking at this right from the side. That was our point 1, 2 about there, and it is at about a z level of 3. So that was what we probably had done in the first day of class. We started talking about section 13. We started talking about explicitly defined functions. Okay, and that is a function of this type, a function where you have z given as a function, some expression that involves x's and y's. Okay, so that was probably our first day of class. Lab day, we would have talked about what basic Calculus 1 and Calculus 2 things Mathematica could do. It can do derivatives, it can do integrals, and then we tried to extend it on to Calculus 3, defining a function of more than one variable and plotting your explicit function z is equal to f of xy. So that ends this first introductory video. See the rest of the videos in this channel for more involved examples.